Subscribers to In the Beginning receive carefully researched ebooks, detailed videos showing real DIY woodworking projects being built step by step, and access to exclusive timber-related content not released elsewhere. Before industrial kilns, timber was left to air dry slowly, often for years. Experienced builders knew that the tree didn't stop changing when it was felled. Moisture moved outward gradually, fibers adjusted to the loss of sap, resins hardened in place. The process of drying was as much about conditioning the wood as it was about reducing weight or preparing it for sawing. Accelerated modern drying interrupts this natural rhythm. The fibers don't shrink evenly. Internal tension builds between the surface and the core. Timber can appear solid and straight on the outside, but internally it may already be fractured along invisible planes. Early exposure to stress or load placement can trigger cracking, twisting, or collapse years later. Rapid kiln drying creates surface stability at the expense of core strength. Kilns today are designed to remove moisture quickly and uniformly. Temperatures are tightly controlled, and air circulation moves water out efficiently. The result is visually consistent boards with low moisture content. On the surface, this seems ideal. Dimensional stability is high, and lumber can be used immediately, but the core tells a different story. While the outside shrinks quickly and hardens, the inner fibers lag behind. The internal stress manifests as micro-cracks that can propagate under load. Old masters observed similar effects when timber dried unevenly over the first winter. They allowed months or years for the moisture gradient to balance naturally. The wood became stronger as it settled. Kiln-dried timber often skips that process. Species respond differently, and modern shortcuts ignore those differences. Softwoods like pine and spruce dry relatively quickly without severe damage if treated carefully. Hardwoods such as oak or ash, however, require slow, controlled seasoning to avoid severe checking and splitting. Modern processing treats most species the same, assuming uniform schedules can be applied across the board. Historical builders knew better. They allowed the drying period to match species, size, and intended use. Oak beams might rest exposed for multiple seasons. Pine could be worked sooner. The goal was functional durability, not speed. The consequence of ignoring this is structural failure in woods that were expected to last centuries. Internal stress affects not just beams, but all joinery. When wood dries unevenly, joints are the first to reveal weaknesses. Mortise and tenon, or dovetail connections, depend on fiber integrity. If the wood around a joint is stressed from rapid drying, it may compress or expand differently than neighboring sections. Over time, this leads to loosening, cracking, or even catastrophic failure. Old builders accounted for this by selecting timber carefully and letting it move before assembly. Modern, fast-tracked lumber can give an illusion of readiness, but rarely offers the same resilience. Resins and extractives harden over time in properly dried timber. These naturally occurring compounds protect the timber from moisture ingress and biological attack, while also stiffening fibers. Accelerated drying forces the resins to behave differently. They can be driven out or redistributed unevenly, weakening the core structure and reducing long-term hardness. Historical observation confirms this. Timbers that were left to settle and dry slowly developed subtle resilience that allowed them to carry loads quietly and evenly over decades. Shortcuts compromise that process, trading long-term strength for immediate convenience. Ancient builders often stored timber in open yards or under shelters that allowed wind and cold to circulate naturally. Moisture loss occurred gradually, moderated by seasonal temperature fluctuations. The wood acclimated to changes in humidity and learned to endure movement before being cut, joined, and stressed. Modern enclosed kilns remove these environmental cues. Drying is fast and predictable, but the wood is untested under fluctuating conditions. Once installed, it reacts to real-world moisture differently, which can accelerate warping or checking. Every board carries the memory of its drying history. Rapid drying locks in tension. Slow, natural drying allows fibers to relax. This distinction is crucial when timber is used structurally. Buildings with rapidly dried beams often require reinforcement years later. Beams that were carefully seasoned may outlast generations of use without failure. Old carpenters could predict timber behavior by observing moisture content, seasonal felling, and fiber reaction. Modern users often assume uniform specifications ensure performance. They do not. If you examine centuries-old buildings, much of the surviving timber shows signs of deliberate, slow seasoning. Internal cohesion is consistent. Cracks are minimal. Joints remain tight. In contrast, timber from modern fast-drying processes rarely exhibits the same long-term stability. The evidence is there. The process works or fails quietly over time. Modern convenience often sacrifices what history perfected. Industrial forestry is designed for speed and efficiency. Timber moves quickly from tree to kiln to construction site. Buyers demand short timelines. Builders respond. But every shortcut taken in drying diminishes the inherent strength of the wood. It may hold up for decades, but eventually the stress manifests. Old masters weren't opposed to efficiency. They opposed ignorance of material behavior. Understanding this process changes how we select and use wood today. Even if it isn't possible to replicate historical drying timelines fully, knowledge of these principles guides decision-making. Choosing species appropriate for the intended environment, allowing lumber to acclimate before installation, and respecting internal stress patterns all improve outcomes. Timber may be more forgiving than we assume, but only if we work with its natural behavior. Strength, longevity, and resilience come from respecting the material. The most durable timber is quiet under stress. It absorbs forces without signaling weakness. Rapid dried wood can appear identical at first, but it lacks the memory and resilience built by slow seasoning. The choice between convenience and longevity is literal. Speed shortens life. Patience preserves it. Historical knowledge remains relevant because wood hasn't changed. Cellulose still shrinks. Lignin still bears load. Moisture still governs decay. Technology may accelerate processes, but it cannot rewrite material properties. Ignoring the effects of rapid drying doesn't eliminate them, it only hides them until failure occurs. For those seeking a deeper understanding of timber behavior, survival, and historical practice, subscribing to the In the Beginning email list provides continued insight. The lessons of slow seasoning are not nostalgia. They are evidence of what works. Observing, respecting, and working with timber as it naturally behaves ensures that the structures we build today can endure the challenges of tomorrow.